Okay, hello there. This is the chapter on the questions and answers on the formula and equations to these questions. So, were you able to balance these equations? To balance the equations, again, you count on both sides of the arrow. How many carbons before the arrow? 2. How many carbons after the arrow? 2. How many hydrogens before the arrow? We have 6 hydrogens before the arrow. Can you see that? 5 and 1, that's 6. On the other side, how many hydrogens do we have? We have 5 and 3, that's 8. You increase the one that is less, so you need to put these so that the carbons are now 6 and the hydrogens are 3 times 6, that's 18. On the other side, after the arrow, it is 3 times 5, 15 plus 3, 18. So the hydrogens are balanced and the rest are all balanced. Now, what about this one? We have how many iron before the arrow? 3. How many iron after the arrow? 1. So you need to put a 3 there in order to balance the iron. Now, usually we leave oxygen till the end. So the hydrogen before and after the arrow are 2. So now we look at the oxygens. Now the oxygen before the arrow is 4. Remember again, every number below something applies only to it. So these are 4 oxygens before the arrow, so I need 4 after the arrow. That means that now I have 8 hydrogens, so I need to fix the hydrogens. Okay, the next one, we have 2 iron before the arrow, so I need 2 iron after the arrow. Now, what do we have? Carbon before the arrow and after the arrow are only 1, so that's balanced. Now the oxygens before the arrow, I have 4. So I need to put something. When I put 2, I will still need to increase it. So actually you will find that you will need to put 3 and 3 in order to balance the oxygens. Okay. This case, I think all of it is balanced. Have you checked to see that it's balanced? Okay, this last one, he already gives you 2 before the KMnO4, so you need to put 2 in front of the Mn. That means you need 16 hydrogens after the arrow, so you need 16 hydrogens before the arrow, and that means you still have 2 to balance the chlorines. So if you put these, you will find that they're all balanced. Okay? Okay, the next question gives you an equation and tells you to write the ionic equation. Now, what do we mean by ionic equation? We said anything that is solid, liquid, or gas remains as it is. It does not ionize. The only species that are ionized are the ones that are aqueous, and the aqueous breaks up. The first part is positive, and the second part is negative. Now, how many positives and how many negatives? They are the same as the valency. So, this equation is broken up like this. The magnesium oxide is a solid, it remains as it is. Now, HCl is aqueous. I have 2 of them. So that breaks up to give 2H plus and 2Cl minus. After the arrow, I have magnesium chloride aqueous. So magnesium is in group 2. It has a valency of 2, so it's magnesium 2 plus. Now, I have 2 chloride ions. Each of them is negative. You don't write Cl2 minus. Each chloride has a valency of 1, so each chloride can have only 1 minus on it. But then I have 2 of them, so it is 2Cl minus, and water is a liquid. It comes down as it is. It does not ionize. Now, if I have anything the same on both sides of the arrow, I need to cancel them. So the 2 chlorides can be cancelled, and I'm left with this. And remember, he says including state symbols, and he already gives you the state symbols, so all you need to do is copy them. Okay? Now, he's giving you a reaction. He's saying write a balanced chemical equation for the reaction. What is he talking about? Tin 2 chloride. Remember that the 2 here indicates that the valency of the tin is 2, and that goes under the chlorine. So you have an equation that looks like this. The tin 2 chloride plus mercury 2 chloride to produce mercury 1 chloride and tin 4 chloride, and then you have to balance. Remember, any chemical equation, any symbol equation has to be balanced. The next question says, write an ionic equation for the reaction of barium chloride with sodium sulfate to form the insoluble salt barium sulfate. Remember that the fact that he says to form the insoluble salt barium sulfate doesn't necessarily mean that that's the only product. You have to think about what are the products. So barium chloride, barium is in group 2, valency 2, the 2 goes under the chlorine. Chlorine, of course, is in group 7, and group 7 means it needs only 1 electron, so its valency is 1. Now, sodium sulfate. Sulfate is SO4, and its valency is 2, so that goes under the sodium. And of course, sodium is in group 1, so it has a valency of 1. Now, to form barium sulfate. Now, barium sulfate, barium is valency 2, it's in group 2. Sulfate, also valency 2, and we said if both of them are valency 2, then they cancel each other and you don't put 2 under either of them. Plus sodium chloride, each of them has a valency of 1, so that's it. You need to balance. Do not leave it without balancing. So I have 2 sodium before the arrow. I have to have 2 sodium after the arrow. 2 chlorines before the arrow. Now I have 2 chlorines after the arrow. So now it is balanced. Then I think which ones are solid, liquid, gas, or aqueous. Now how do I know? You should realize that most of the chlorides are soluble except silver chloride and lead chloride. So barium chloride, barium sulfate, he already says it's insoluble. The barium chloride is aqueous, sodium sulfate, sodium anything is aqueous, sodium chloride is aqueous. Now that means anything that's aqueous has to be ionized. So the first one takes a positive, and the number of positives or negatives is the same as the valency. So barium is valency 2, so it has 2 positives. Now chloride, each of them is valency 1, but I have 2 of them. Sodium, each of them is valency 1, but I have 2 of them. Sulfate is valency 2, and I have only 1 of that. To give barium sulfate solid does not ionize. A solid does not ionize. Now, sodium chloride, sodium, I have 2 of them, but each of them has a valency of 1, so Na plus and Cl minus. Now, then I cancel whatever is the same on both sides of the arrow. So I have chloride there and chloride there, so that is cancelled. Anything else? Sodium and sodium. Anything else? No, I write the rest of it. So what I end up with is barium plus sulfate to give barium sulfate. In some questions, he will not give you any equation and he will just tell you, write the ionic equation for formation of barium sulfate, for example. Now, you should realize that barium sulfate, without going through any of these, barium sulfate is made from which ions? It's made from barium ions and sulfate ions, even if we don't go through all of this. So remember that he doesn't need to give you an equation. He could just tell you, write the ionic equation for formation of the insoluble salts barium sulfate. You should realize that barium sulfate is made from barium ions and sulfate ions. Okay, balance the following ionic equations. Again, to balance ionic equations, we said you balance the atoms and then you balance the charges. So, how many lead before the arrow? 1. How many lead after the arrow? 1. How many hydrogens before the arrow? 1. How many hydrogens before the arrow? 2. So I need to fix that in order to have 2 hydrogens and 2 oxygens. Now it's balanced. Now, are the charges balanced? Now, before the arrow, I have 2 positives and 2 negatives. That means an overall of 0. After the arrow, I don't have any charges, so that's an overall of 0. So now the equation is balanced. Okay, the same thing here. Aluminium atom, 1 before the arrow, 1 after the arrow. Hydrogen, 1 before the arrow, 3 after the arrow, so I need to fix that. So now I have 3 hydrogens and 3 oxygens before and after the arrow. Now, are the charges balanced? Yes, before the arrow I have 3 positives and 3 negatives. Can you see that I have 3 negatives before the arrow? So that is a balance of 0, and after the arrow no charges, so it's also a balance of 0. So that is balanced. Okay, try balancing this one. 1 aluminium before the arrow, 1 aluminium after the arrow. Now, how many hydrogens before the arrow? I have 3. Anything outside the bracket applies to everything inside the bracket. So there I have 3 hydrogens plus 1, that's 4. So before the arrow, I have a total of 4 hydrogens. After the arrow, I need to fix that to make it 4. So now I have 4 hydrogens. Now what about the oxygens? Are the oxygens fixed? Well, before the arrow, how many oxygens do I have? I have 3 plus 1, that's 4. Now after the arrow, I have 2 plus 2. Remember that anything at the beginning applies to everything after it. So when I say I have 2 H2O, that means I have 4 hydrogens and 2 oxygens. So now it is balanced. Okay, this one. 2 chlorines before the arrow, 2 chlorines after the arrow. That's correct. 1 hydrogen before the arrow, 2 hydrogens after the arrow. So I need to fix that. But when I fix it, I will find that I need to fix the oxygen. So in the end, you will have to have something like this. Okay. Now, this one, thiosulfate, 2 minus plus iodine. Okay, how many sulfur before the arrow? 2. After the arrow, 4. So I need to fix that. So now I have 4 sulfurs, and the iodines are fixed, and the number of negatives or positives, how many do I have? Before the arrow, I have 4 negatives. Can you see that? 2s2o3, 2 minus, that is 2 times 2, that's 4 negatives. After the arrow, I also have 2 negatives and 2 negatives. So this is balanced. Okay, write an ionic equation for the reaction of silver nitrate with potassium chloride, and he's saying a white precipitate. Of course, the word precipitate means it's a solid. A white precipitate of silver chloride, but you should realize that you don't just get silver chloride. You look for the rest of the equation, so you're left with silver chloride plus potassium nitrate. Now, how do I know which is aqueous and which is solid and which is liquid? He already tells me that the silver chloride is a solid. Now, anything nitrate is aqueous, any potassium something is aqueous. You should realize that. We have said before that sodium salts, potassium salts, ammonium salts, anything nitrate, all of these are soluble, so they're all aqueous. So these are the state symbols. Now, we need the state symbols in order to know which one is going to be ionized. So here we are going to ionize everything except the AgCl. So Ag plus, because the valency of silver is 1, valency of nitrate is 1, potassium 1, chloride 1, and so on. And whatever is the same on both sides of the arrow will be cancelled. So which one is the same on both sides of the arrow? Nitrate and potassium. What are we left with? Again, if he just asks write the ionic equation for formation of silver chloride, you should realize that silver chloride is made from which ions? From silver ions and chloride ions. Okay? Write out an ionic equation for the reaction of zinc with silver nitrate. Well, this is zinc plus silver nitrate. Again, you need to write the balanced chemical equation, balance it, decide which one is solid, liquid, gas, aqueous. Of course, any metal like zinc and silver are solids. Any nitrate is aqueous. Ionize the ones that are aqueous. So the zinc remains the same, but the silver nitrate becomes silver plus and nitrate negative. And we have 2 of each. To give zinc 2 plus, with nitrate we have 2 of them. And the silver solid remains the same. Now we cancel what is the same on both sides of the arrow, and I end up with this. Okay? Okay, good. Write an ionic equation for the reaction of sodium hydroxide and hydrochloric acid. Again, you write the symbol equation, balanced if it needs balancing, so that's what we have. Sodium, anything is aqueous, any acid is aqueous, and the only thing there that is not aqueous is water, which we regard as a liquid. Ionize everything else except water, cancel the ions that are the same on both sides of the arrow, and you end up with this. So that is what we call your net ionic equation. Okay? Okay, calcium chloride can be prepared by reacting calcium carbonate with dilute hydrochloric acid. The ionic equation for the reaction is this. Now, which of these should we choose? Well, try to ionize it. Don't just look at it. So, calcium carbonate is a solid, so that should remain as it is. And then if you ionize HCl and calcium chloride, you will find that both of them will give you chloride ions. So the chloride ions will be cancelled. And what you're left with is calcium carbonate plus 2H plus to give calcium 2 plus water, carbon dioxide. So my answer is B. Okay? Consider the following ionic equations. When these ionic equations are combined, the full ionic equation is which one? Remember, in order to combine ionic equations, the number of electrons must be the same. So I have to multiply that first one by 2 and the second one by 3. That makes the number of electrons equal. I cancel the electrons and I'm left with this. So that means that my answer is D. Were you able to do all of these? I hope that you have tried it. And if you did not get the correct answer, I hope that now you understand the correct answer. Okay, complete the ionic half equation for the reduction of dichromate ions to chromium 3 ions. So he already tells me that it should give chromium 3 and I have an H plus. So when you have positives on one end, you need electrons on that same end so that the positives and negatives will cancel, because on the other side there are no positives. Actually there are 3 positives, so you want before the arrow to be also a net of 3 positives. But first you balance the atoms. So before the arrow I have 2 chromium, so I need to put 2 chromium after the arrow. Now before the arrow I have 7 oxygens. I put this and then I fix the hydrogens, because if I did the other way around it will mess things up. So now I have a balanced atoms, balanced number of atoms, but I need to balance the charges. So after the arrow I have how many charges? After the arrow I have 2 times 3 plus. So after the arrow it's 6 plus. So I want before the arrow to be total 6 plus. I have 2 minus 14 positives, so that means I have 12 positives. And that means that I need 6 electrons to make it 6 positives. So that is my equation. Okay? Write the equation for formation of boron nitride from boric acid and ammonia, state symbols. And so he just wants, again, I'm going to remind you, when he just says write the equation, he means balanced symbol. If he does not mention the word, if he does not say write word equation, that means he doesn't want word. That means he wants symbol, and the symbol has to be balanced. So this is what he said. He said the formation of boron nitride, that means after the arrow I have boron nitride, from boric acid, so I'm starting with H3BO3 and ammonia. Of course you should realize that if I end up with boron nitride, I must have something else. So what am I left with? I'm left with water. This is like acid plus base to give salt plus water. Then you balance. You have to balance 3 hydrogens. For the arrow I had 6 hydrogens. So after the arrow now I have 6 hydrogens, 1 boron, 3 oxygens. Now I have 3 oxygens, so now it is balanced. Okay, he says an excess of powdered zinc is added to sulfuric acid. Write the ionic equation including state symbols. So zinc is a solid, sulfuric acid is aqueous, all acids are aqueous. So what would this give me? You should realize that this gives zinc sulfate plus hydrogen. And then you balance if it needs balancing. Obviously it doesn't. Then you need to ionize. Ionize whatever is aqueous. So I'm ionizing H2SO4 and zinc sulfate. Now what is the same on both sides? Sulfate ions, and I end up with this. And do not forget, if he asks for state symbols, please give him state symbols. Okay, the reaction between a potassium halide and silver nitrate, the ionic equation for this reaction is, again, anything that's aqueous needs to be ionized, and whatever is the same on both sides of the arrow will be cancelled, and I'm left with X minus plus Ag plus to give AgX. Okay? Copper plus 2HCl to give copper chloride plus water, the ionic equation, again, you should realize that the copper oxide is a solid. It comes down as it is. I have chloride before and after the arrow, so that is cancelled, and I'm left with the equation in B. Okay? A solution of strontium nitrate was prepared from solid strontium oxide and dilute nitric acid. So write the equation. Strontium nitrate was prepared from strontium oxide, and he tells me it's a solid. Nitric acid, I should know, is aqueous. And sulfur dioxide combines with water and oxygen in the atmosphere to produce sulfuric acid. So he wants a balanced equation including state symbols. Sulfur dioxide, water, oxygen to give sulfuric acid. You should realize that sulfur dioxide is a gas, water is a liquid, oxygen is a gas, sulfuric acid, any acid, is aqueous. And then you need to balance. So how many sulfur before the arrow? 1. How many sulfur after the arrow? 1. How many hydrogens before the arrow? 2. How many hydrogens after the arrow? 2. So far so good. But the oxygens, how many oxygens before the arrow? I have 2 plus 1, that's 3, plus 2, that's 5. So I have to increase the ones after the arrow. That means that now I have ruined the hydrogen and ruined the sulfur, so I need to fix that. Now I have 2 sulfur and 2 water. So let's count again. So 2 sulfur, 2 sulfur. 4 hydrogens, 4 hydrogens. Now the oxygens before the arrow are how many? 4 plus 2, that's 6, plus 2, 8. After the arrow it's 2 times 4, that's 8. So now it is balanced. The ionic half equation for the redox processes are these. Use these half equations to deduce the full ionic equation. So you're supposed to, I think you already balanced them, so you just need to fix it so that the electrons are the same on both sides of the arrow. So I'm going to multiply the second equation by 5 so that in both equations I have 5 electrons. Then cancel the 5 electrons and add up whatever is left. So this is what I'm left with before the arrow, and this is what I'm left with after the arrow. Okay. Chlorine gas is bubbled into aqueous potassium iodide. Give the ionic equation. So chlorine gas, remember chlorine is diatomic, Cl2. Potassium iodide to give I2, which is diatomic, plus KCl. You should realize that chlorine is a gas, potassium iodide, we said potassium, anything is aqueous. Now iodine is a solid, because, or it should be a solid or dissolved in water, but it is a solid. Okay, so balance it. I need 2 iodines after the arrow, 2 iodines before the arrow, 2 potassiums, 2 potassium, so now it is balanced. He says he doesn't need state symbols, so actually I shouldn't put state symbols. He wants ionic. I'm putting it only to see which one should be ionized. Okay, so the chlorine is a gas. Remember we said solid, liquid, gas do not ionize. So chlorine remains as it is, iodine remains as it is, and ionize the rest. I cancel anything that's the same on both sides of the arrow, and this is my net ionic equation. Okay, which of the following has the correct state symbols for the reaction? Okay, you should realize that magnesium oxide is a solid, and actually all the choices shows magnesium oxide is a solid. You should realize that HCl is an acid. Acids are aqueous, so my answer is A or B. Now magnesium chloride, you have to realize we said most of the chlorides of group 1 and 2 are soluble except chlorides of silver chloride and lead chloride. That's what we deal with. So magnesium chloride would be aqueous, so my answer is B. Okay, sodium carbonate, ionic equation. So we wrote the ionic equation, we cancelled whatever is the same on both sides of the arrow, and I end up with this product, which is answer C. Okay, try this, make sure you understand. Carbon dioxide is a gas, water is a liquid, so these remain the same, everything else is ionized. Okay, write a balanced equation for the reaction between nickel carbonate and dilute nitric acid. Nickel carbonate is nickel 2, so the valency of nickel is 2, the valency of carbonate also is 2. So that's how you write nickel carbonate. Nitric acid, nitrate, of course, valency 1, so that is HNO3. So what should this give you? You should realize that any carbonate plus acid will give what? Will give a salt, so in this case it's nickel nitrate plus carbon dioxide plus water. Now, which ones are the state symbols. Of course, the carbon dioxide and water, carbon dioxide is a gas and water is a liquid. Before that, we have to balance, of course. So let's balance that. So that is 2HNO3 to balance the hydrogens. Now, the nickel carbonate is a solid. Okay? Most carbonates are solids, except sodium, potassium, ammonium. Remember that. Carbonates are not soluble. Carbonates are solids, except sodium carbonate, potassium carbonate, ammonium carbonate. Okay? Acids are all aqueous. Anything nitrate is aqueous. Carbon dioxide is a gas and water is a liquid. Okay? And that's what he wants. He doesn't need ionic equation. Okay, magnesium carbonate readily reacts with hydrochloric acid. So magnesium carbonate, hydrochloric acid. So this should give, again, carbonate plus acid gives the salt plus carbon dioxide plus water. Now, magnesium carbonate, we said carbonates are, okay, he doesn't want state symbols, he wants to balance. So this is 2 hydrogens to balance the hydrogens after the arrow, and I think that's the end of it. Okay. Iodine pentoxide, remember that if he gives you something that is strange you've never seen, he usually gives you the formula. So iodine pentoxide, he says, is a solid. The iodine pentoxide decomposes to give iodine and oxygen. Write the equation for this decomposition. He doesn't want state symbols, but you have to balance it. So the iodines are balanced, but the oxygen is not balanced. So I need 5 and 2, and now I need this. So now it is balanced. Okay. Barium chloride is made by reacting solid barium carbonate with dilute acid. Write the ionic equation. And he already wrote the equation for you. So all you need to do is ionize whatever is not solid, liquid, or gas. So the barium carbonate remains as it is. The acid is ionized. Barium chloride is ionized. Carbon dioxide and water remain the same. And you cancel whatever is the same on both sides of the arrow. And you end up with this. Okay. Thermit reaction between iron 3 oxide and aluminium powder produces aluminium oxide and iron. So aluminium oxide, valency of aluminium is 3, valency of oxygen is 2, so this is how we write aluminium oxide, plus iron, and then you need to balance. You have 2 iron before the arrow, 2 iron after the arrow, and it's balanced, right? Okay. Now, complete the ionic equation for this reaction. Again, the solid remains as it is. The sulfuric acid has to be ionized. The copper sulfate has to be ionized. The water remains as it is. Cancel what's the same on both sides of the arrow, and you end up with this one. Okay? An alkaline solution is produced when barium reacts with cold water. Now, you should realize that barium reacts with cold water. Any active metal that reacts with cold water gives the hydroxide plus hydrogen. That's something we studied and we're going to repeat it again. But any reactive metal with cold water will give the hydroxide plus hydrogen. We need to balance, so we put a 2 here so that we have 4 hydrogens before and after the arrow and 2 oxygens. So that is balanced. He says include all state symbols. Barium is a metal, so it's solid. Water is a liquid. Barium hydroxide is an aqueous, and water is, because even if you don't know that barium hydroxide is aqueous, he says an alkaline solution is produced. So that means barium hydroxide is aqueous, plus hydrogen, of course, is a gas. Dilute hydrochloric acid is added to the solution produced in A. So he added hydrochloric acid to the barium hydroxide. Now that would give you what? That would give barium chloride plus water, acid plus base. And then we need to balance. And here he doesn't need state symbols. So to balance, I have 2 chlorines after the arrow, so I need to put that to... I need 2 oxygens before the arrow, so I need 2 oxygens after the arrow. Now it's balanced. I have 4 hydrogens before the arrow, 4 hydrogens after the arrow, 2 oxygens before the arrow, 2 oxygens after the arrow. So now it is balanced. Okay, so that's the end of this question and answer session.